Hello everyone, welcome to the session on analysis and design of algorithm. So in today's session, let us discuss what are all the various steps involved in problem solving. So in order to solve any kind of problem, we need to go through with this procedure, okay, and along with this we are going to learn what are all the basic types of problems we have. Okay, so in order to solve it. So but in the previous class what we have learnt is, so what is the agenda, so that is like so what is the algorithm, and then so why we need algorithm, so what is the importance of that algorithm, and then what is the notion of that algorithm, what are all the characteristics of algorithm, so how we are going to represent the algorithm, that is nothing but the notation of the algorithm, and then so few of the difference between the algorithm and the program, right. So in the previous session we have learned. So now, so let us learn how the problem solving is achieved. So what are all those steps in order to get the solution for the given problem. So here we have a flow chart, so in order to solve the problem. So very first step to solve our problem is to understand the problem. So first step for solving your problem is we need to understand the problem clearly. That means that, so here, so if without knowing what actually the problem statement is, we can't get the solution for the given problem, right. So because of that reason, so the foremost, so first we need to look into the what is the problem has been given. So in order to think that, so whether, so we need to go with what kind of data is available, those are all things we need to think of, and also we need to come up with the variable possibilities whatever we have, and also for all the algorithm, once you write the algorithm we should need a input, right. So finite set of inputs are necessary. So in order to execute your algorithm, so if you don't have a input, then you can't, so you can't say that whether your algorithm is giving the proper result or not. So whatever the algorithm you are going to write, that should work for all the kind of inputs or else all the legitimate inputs. So we can't say that for almost all the inputs it works. No, we should not talk like that. Okay, the algorithm whatever you have written, so whatever the kind of input might be, it should work accordingly, okay, and it should give you the appropriate result what you are expecting for. So because of that reason, here in the first step we need to know what is the problem statement is, and what is the input is, and what is the output is. Okay, the second step, so what is the second step is to model development. So the next step is we need to develop a model, that is nothing but here using some mathematical equations or any the procedure for solving the problem we need to identify. So which mathematical equation is suitable for solving those kind of problem we need to come up with. So mathematical model we need to build, okay, and also we need to look into the three things. So the first one is the computational need or capabilities. The first thing is we need to come up with a computational capabilities. That is, see, whenever we are get the algorithm, definitely we need to program it, right. So whenever we are programming it, so before going to write the algorithm we need to think of, so whether your algorithm whatever we have written, does your system support that kind of algorithm. If you have, as we know that some of the systems are non-human architecture. So non-human architecture architecture only executes a sequential programming. That means that the programs are going to be executed sequentially, step by step. After one instruction, after the next instruction, it's going to be executed, right? So here in the model development, you need to come up with this. So whether you are writing the sequential algorithm or the parallel algorithm. So if you are going for sequential algorithm, yes, of course, that non-Newman architecture is enough. But if you are writing in order to solve the algorithm, parallel algorithm, by that time we need to go for the computers which can solve the parallel programming, which supports the parallel programming. Okay, so those kind of capabilities we need to identify. The whatever the computational devices we are searching for, whether it supports a sequential programming or whether it supports a parallel programming, based on that we need to write the sequential algorithm or parallel algorithm. If your system support a sequential one, go with a sequential flow. Otherwise, if your computational device supports a parallel algorithm, then you can write the algorithm in such a way that your algorithm works parallelly and get the solution very soon. Okay, so but you need to look into the capability of your machine. Okay, so that is the first thing in model building. And next one is we need to look into, whenever we are solving the problem, we need to look into two aspects: whether you were expecting for the approximate result or the deterministic result. That means that, so if the approximation in the sense, say for example, if you are calculating the square root of some number like 3. So by that time it is not going to give you the exact result, right? So it is going to yield you the 1 point something recurrence it is going to give, right? So that kind of, so here we need to specify whether this algorithm yields you the approximate result or the deterministic result. So that we need to take care of. So approximate or deterministic means exact result. So are you writing the algorithm for getting the exact result, or are you writing the algorithm for getting the approximate result? We need to think of. Okay, and next thing is, along with this we need to identify the data structures. So here, whether we the problem whatever you have and the algorithm whatever you have written, so which supports some kind of, if it is work good on arrays, then you need to go for arrays. If it is works on trees, then you need to go with the trees, or else if it is good with the linked list, then you have to go with the linked list. Based on the problem and its computational devices capability, we need to go with the data structures. Okay, so what kind of data structures is suitable for your problem, that data structures has to be followed. Okay, so once you come up with this model development, the next step is to design an algorithm. So the next step is design an algorithm. So algorithm can be represented using our our natural language like English like statements, and then the pseudocode, or we can have a flow chart, right? So here, using various designing techniques, we can come up with a solution, and those solutions can be represented using natural language, and then pseudocode, and then flowchart. So natural language, whatever the English like statement we can say. Okay, so whatever the procedure you have, you are going to take a pen and pencil, pen, paper and pen, and you are keep on writing the whatever the procedure you want. So that is, so what is the first step, what we need to do, so what the next step. So those are all things based on the operations. You need to write down all the procedures in English like statement. But here some statements will be there, like might be, and some statements will leads to ambiguity. So instead of going with the natural language, it is better to come up with, in order to overcome that particular problem, we need to go with the pseudo code. So what is that pseudo code is? The pseudo means false. Code is nothing but our algorithm procedure. That doesn't mean that whatever the algorithm you have written or the steps you have written is wrong. No, it is not like that. It's a false code. That is, your algorithm look like a program, but it is not actually the program. Why? Because it's a pseudocode is a combination of program and your algorithm, natural like English statement. So here we doesn't have any kind of syntaxes. We don't follow any kind of syntaxes. That's why it is called as a pseudo code. Okay. So the next one is, we can represent your algorithm using flowchart also. So in BCA or your previous year, you would have written the algorithm using this flowchart itself, right? So write this flowchart for adding two numbers or finding the greatest of two numbers, like that. So you would have written that, right? So in order to represent our algorithm, you can have a English like statement, and also you can write it in a pseudo code or a historical way. Then you can go for the flowchart. So that will yields you the look and feel. So that means that by looking into this the picture itself, you will come to know so how exactly it works. Okay, so that is the flowchart. So this in these three ways we can we can write the algorithm. Along with this, so here we have a various designing techniques for designing the algorithm. So the various designing techniques are the brute force, divide and conquer, decrease and conquer, transform and conquer, and then dynamic programming, and then we have greedy method. So likewise, so many methodologies are there to solve a particular problem or to write the algorithm. Say for example, if you consider the brute force approach, it's a straightforward approach. We based on the problem statement, whatever we have got, based on that we are going to perform without doing any modifications or without thinking any other alternatives. Okay, so that is the brute force approach. So coming to the next one, that is divide and conquer approach. In the divide and conquer approach, the problem is going to be divided into sub problems. So until unless that sub problem solution is easy to solve. So once it is solved, the sub problem, you are going to conquer all the sub problem, and then you are going to combine, or you can do any operation. So we are going to get the solution for the original problem. Okay. And decrease and conquer, there also we are going to divide the problem into sub problems, and then we are going to combine or transform the solution for whatever the solution you have obtained for the sub problem, and that will be transformed to the original problem solution or a complex problem solution. Okay, this is how we can calculate the values or a algorithm. So next is the transform and conquer, and the next one is dynamic programming and the greedy method. So some of the combinatorial problems can be solved using this greedy method and the dynamic programming method. And using transform and conquer method, so here we can transforming from one level to another level. So that is binary to ternary. So like that we can convert the operations also. Okay. So next is, once you design the algorithm, we need to prove the algorithm's correctness. As you know that, so here, so for the various inputs we need to check and we need to identify whether your algorithm is giving the correct output or not. So in order to verify it, we are going to use a mathematical induction method for verifying whether the algorithm is yielding the correct output or not. Okay. So we need to go with what? Not to prove the algorithm correctness, we need to use the sorry programming algorithms, the correctness. In order to prove the algorithm's correctness, we need to use the mathematical induction method. Okay. So the next, after once you validate your algorithm is giving the correct result, then we need to go with the analysis of the algorithm. So here we have a so multiple techniques, right? So in order to solve a single problem, we have multiple techniques. Using those techniques, you can have n number of solution. Among those n number of solution is going to give you the same result. But the thing is, so whether which algorithm is going to give you very quickly, which algorithm will yield the result without using any temporary variables or without using the extra spaces. Okay. So if that the performance of the algorithm increases, but that time the system is increases, so those kind of algorithm can be treated as a better algorithm. So how can be done? That can be done used by analyzing those algorithm. So here analysis of the algorithm is based on two factors. One is time and another one is the space. So here, if you are calculating the complexity of the algorithm based on the time factor, then it is called as a time complexity. If you are calculating the analyzing the algorithm based on the space, then it is called as a space complexity. Okay. So in the next coming sessions we will discuss more on how to analyze the algorithm and what are all the various steps for analyzing the algorithm. Here we are basically based we are doing the algorithm analysis based on time only, not on the space. Okay. So the next one is, once you get the better solution, like among all the algorithms, so if the performance is very high, that particular algorithm can be treated as a better one and that can be implemented. At last we can implement that particular algorithm whatever we have obtained from the previous step. Okay. So these are the different steps. After that we can do the reporting and documentation, and then you can code with the appropriate programming languages. Okay. So now again let me repeat the steps. What is the first step? We need to understand the problem statement. So what is the problem is, what all the input is, what all the output is, we need to identify. Next step is to model development. So model development in this, so we need to concentrate on whether you are going to write the programming in a sequential order or we are going to write it in a parallel order. So whether your algorithm executes in a sequential order or parallel order. So if your machine, whatever you are executing, if it supports a sequentially, then you have to go with sequential only. Or if your machine is supporting the parallel computing and if it is suitable for your problem solving, then you can go with the parallel algorithm also. And then we need to come up with a exact or approximation algorithm. So we need to think of whether, as we know that in the first step itself we know the input and we know the output. So what kind of output we are expecting, we know that. So for that we need to come up with whether your algorithm will yield you the exact result or an appropriate result we need to look into. Next is the data structure. Obviously, we need to select the appropriate data structure for your problem solving. Next is design. So, using various techniques, you can design your algorithm. Once you design your algorithm, you can represent using flowchart, pseudocode, or the English like statement. So, it is better to write in a pseudocode so that it will be easy for coding or programming. Okay. So, once you design your algorithm, we need to prove its correctness. Proving its correctness is nothing but here based on what? So, mathematical induction method, we can prove its correctness. Whatever the required output we are expecting for the same result we are obtaining. So, that we need to clear here. That doubt we need to clear here. And then next method is analyzing the algorithm. So, based on time and space, we are going to analyze your algorithm and we are going to say that which algorithm works better than another algorithm. Okay. So, finally, we need to implement the program. So, whatever the algorithm we have, we need to convert into an appropriate programming using the appropriate programming language and we need to program it. Okay. So, finally, you can get the result in your system. So, this is how we can solve the problem using these various steps. Okay. So, next let us see what are all the different types of problems we have. The types of important problems. So, the various types of problems are, so we know that almost all are knowing about sorting, searching, so next is string processing, some graphical problem, some combinatorial problem, geometrical problem, and some numerical problem. Okay, so these are the different types of problems come across in a real world scenario or the system. Okay, so now sorting, as you know that, so here we need to compare the things and we need to arrange the elements in some order. Okay, either it might be in ascending order or it might be in descending order. Say for example, if I want to sort the student list based on the alphabetical order, then we can go with this sorting technique, or else sorting the student database based on the increasing order of the marks, or else sorting the database of the student based on the USN. So, like that you can make the, do the sorting. As if you look into your Facebook account, there also if you are giving some name, it is going to list all your friend names in some sorted order, right? So, in the back end, what is it working? The sorting algorithms only. So, in this coming sessions, we are going to learn various sorting techniques using some of the methodologies. Okay. So, next is the searching. So, searching is nothing but if we are finding for any record, if you are finding for your friend in the Facebook, so whatever it is. So, just by clicking one name or browsing anything, so in the web browser, so if you are finding for any notes or if you are finding for any video, by that time in a fraction of second you are going to get it, right? How? In the back end we are applying the what? The searching algorithms. Okay. So, that is the searching problems comes, and then next is the string processing problem. So, string processing problem is nothing but string matching. So, that is by comparing the string between So the text and the string pattern. So whatever the pattern we have, we are going to compare it. So whether that particular string is present or not. So this, okay, and then some graphical problems. So in order to represent this graphical problem, so the graph, we are representing our problem in terms of graph. So say for example, if you consider the communication network. So in the communication network, so we are going to represent our problem in the form of graphs. So either we can find out the routing algorithm, so in order to find out the shortest path, or to avoid the flooding, all those things. By that time we can go with these algorithm. Various techniques can be used and we can solve this graphical problem also. And then we have a combinatorial problems. So like if you want to solve the problems like permutations and combinations, those problems comes under this combinatorial problem. And next is the geometrical problem. So that is the problems which deals with points, lines, curves, and then polygons with different types of shapes of geometrical problems. So which comes under this one, that is closest pair algorithm, convex Hall algorithm. So comes under this geometrical problems. And then numerical problems. So here we are going to solve some of the kind of equations or equation computing, or else if you are doing the integration or evaluating various type of functions by that time. So those kind of problems comes under this numerical problems. So now we are going to solve these problems under this we are going to learn how to solve these kind of problems using various techniques called as in brute force, divide and conquer, and then decrease and conquer, transform and conquer, dynamic programming, greedy method, and by input enhancement, branch and bound, backtracking. So many methodologies are there. We can use that methodology and we can get the solution for your problem. So this is how you can calculate the value for your we can identify the solution for your problem. Okay, so so let me wind up this session. So I guess you are getting whatever I am delivering. So thank you very much. In the coming session, let us discuss on how to analyze the algorithm. What is the framework for analyzing the algorithm? Okay, thank you.